Good morning, everyone. Thank you for joining Megger webinar. I'm Grace and I'm the marketing manager for meggereastasia, and I'll be the moderator today. Today is a live webinar. You automatically muted to prevent any background noises. During the webinar, if you have any questions, please type into the question box, which you can see on the left of your screen. We'll answer your questions in the Q&A session. At the end of the webinar, please have a fill in the survey, which you can see on the right-hand side. We'll be sending the presentation materials to those completed the survey. You can download the attendance certificate after you have finished the webinar and completed the survey. And the recording of this webinar will be sent to you in 2 days' time by email. Today, our topic is DGA, the source case analysis by Megger. And our speaker is Mr. Smit Lertsethawanich, who is the application engineer of transformers in Thailand. He's formerly part of Megger distribution company and have worked in the power plant in Thailand, which has equipped him with extensive experience in the field of transformer testing. He's also visionary and aims himself to be expert in advanced transformer testing and diagnostics. He is now part of the global transformer team to facilitate and promote the innovative 1 Hz transformer testing technology in the region. Sorry, Smith, I will pass the time to you now. Thank you for sharing.
Okay, thank you very much, Grace. Morning, everyone. My name is Smit. As Grace introduced, I'm the application engineer of Megger. If you have any question about the transformer testing or anything about the DGA, please feel free to reach me or contact me through emails or anything. I will show up the slide on my last slide. Okay. We have the very first equipment or the instrument for testing or measurement the diesel gas inside of the transformer. We call it Insulogic G2. This one, our name came from the Insulogic, insulation, plus the logic, means the logic that can help your installation. The Insulogic G2 is an equipment to detect an alarm, so it can help you to protect your transformer through detection anything happen in your transformer and alarm to the user. It is not the unit that dedicate for analyzing. I didn't say that it is totally cannot analyze, but it is not dedicate for analyzing. To use it is more simple and easy to monitor the value inside of your transformer. And I will talk a little bit more about the reason later, but this is the things that I need to highlight, that this is not for the analyzing. And I would like to introduce a bit about a little basic inside of your transformer. First, I would like to talk about what is the material inside your transformer. First thing is the winding or electrical conductor. It is made of the copper or aluminum. Its job to let the electricity flow through it as easy as possible. If there is some obstruction, such as the untightened bolt or bad connection, it will cause the high temperature inside of your transformer. Next is the core. It is the path for letting the flux flow, which this core also have the a function to let the flux flow inside of the core. It also can create the heat through the losses, such as the eddy current losses or hysteresis losses, or the magnetic losses, which all of those can create a heat and effect to the system inside your transformer. Third one is the solid insulation, or the paper that we know. This paper, normally you understand that it is using for to be the dielectric inside of your transformer, but absolutely that is not the only job for the cellulose. The cellulose can also provide the mechanical strength and dielectric spacing inside of your transformer. That meaning is if there is a movement or collapsing of the strength of those paper also can create the damage inside of your transformer. The next is the last main material inside of your transformer, the insulation oil. This insulation oil has also the main job to prevent the discharge inside of your transformer and also can increase maintain the dielectric, and also we have to add the additive to make the aging of that insulation oil preserve as long as possible. If there is a water or oxygen leak from the outside, it also can create the effect or damage to those insulation inside of your transformer. What is the cause to damage of your transformer? We can separate into main three causes. First is the mechanical fault. Second is the electrical fault. And the last one is come from the operating. We can easily understand mechanical fault is from the any physical action such as the manufacturing, transportation, installation. All of those things can create the leakage of water and oxygen inside to your transformer, or create the bad contact when you miss installation, or tap changer does not operate properly. So all of those can create a mechanical fault and can lead to the fall of your inside of your transformer. Second is electrical fault. Why we separate the electrical fault like this? Because the electrical fault gives the different signal, such as the partial discharge. It also can create from the bubble inside of your transformer or the low breakdown voltage. If you detect from the different sensors such as the PD detection, you may find this. But if there is some heat spot or hot spot inside of your transformer, you may not find those things because it is not a PD, right? The next is electrical fault is low discharge and high energy discharge. Though all of those two also depends on the insulation condition. Last is the operating. Very simple. If you operating the transformer in the overload or very high load, you also can create the heat inside of your transformer. Those heat may not damage your transformer directly, but it also accelerate the aging of your insulation, such as the paper. If you heat the paper, you can damage the chain of those paper, and when you damage the chain of those paper, will create the water inside of your transformer, and that those water will accelerate the aging of the insulation. I will talk a little bit about the gas formation here so that you can understand a little bit more why we choose the gases to monitor, and how we choose to monitor those gases. Inside of your transformer, I have already discussed that we have two main insulation. First is the insulating oil. Second is the cellulose or the paper inside of your transformer. When those insulation got energy, it will oxidate or burn or have some chemical reaction, which can give a result or produce the gases inside of your transformer. It's the same concept such as you burn some of the paper or you burn some of the water that make the water became to vaporize. But inside of your transformer, there is a insulating oil, which the property of the insulating oil also have different from just normal water, which is H2O. is full of the carbonized chain, which also yield or give the result at the different level. If we sequence or we sort the gases that will generate according to the energy that we give to those in solution, the first gas that we got will be hydrogen here. It is the gas that needs the lowest energy to produce. Next is methane, ethane, ethylene, acetylene. Acetylene is the highest gas that needs energy. Normally, acetylene will be created at 700 degrees Celsius, such as from arcing or high discharge energy inside your transformer. Cellulose is much simpler. If it got energy, it will produce carbon monoxide and carbon dioxide, such as you burn some of the paper. This is the graph that shows concentration of each gases that occur inside your transformer according to temperature and fault type. Um, okay. First, here, if you measure and found only hydrogen, that means this is the catalytic reaction of water with the steel, which can create the hydrogen inside of your transformer. This is the graph that is not in showing the increasing trend of your fault. It is the graph to analyze what is the fault inside of your transformer. And such as this PD. If you have the hydrogen here, around 95% when you measure, and you also have the methane here, around maybe 10% here, that means you should have PD inside your transformer. I would like to show you this because this is not the trending, such as if you have a PD inside of your transformer, the hydrogen will not reduce the concentration according to this curve. No, this curve is just for not analyzing something that happened inside your transformer. You measure all of those gas concentration and you found out that, okay, this is PD. Same as the other fault type here, such as S is straight gassing of the oil, T1 thermal fault, the temperature is less than 300 degrees, O is overheating of the oil or paper at temperature less than 250 degrees, C is probability of the carbonization of paper, T2 is thermal fault 300 degrees to 700 degrees, and T3 is 700 degrees Celsius. D2 is high energy discharge. D1 is the low energy discharge. I would like to highlight a little bit here at this region because the fault in this region are likely to be the starting fault or the fault that start to create and leads to the severe problem. And this is also the region I would like to highlight because this region can lead to severe fault. This region of the fault will be created if inside of your transformer has the temperature more than 700 degrees Celsius or the arcing fault or very high discharge fault like really hot spot. Actually, the hot spot should not create like this, but just for example, because in this region can create the explosion or really damage to your transformer. This is the diagram of the fault reaction that happened inside of your transformer. From the diagram, you can see a lot of things that happen inside your transformer. For example, water here. If your transformer has the oxygen inside, of course, you cannot get rid of the oxygen down to zero. But if there is a leakage from the outside, that means some oxygen will come into your transformer more. It can oxidize with the paper and create the carbon monoxide or carbon dioxide. And those paper also uh, create the hydrolysis process and create the water inside of your transformer, which also accelerate the aging of your paper. And the water can have through the leakage from the outside, from the external here. If there is a temperature increasing inside your transformer, it also can destroy the change of your cellulose molecule and create the water. These are the things that happen inside of your transformer. I would like to show you this because all this thing will create the gases inside of your transformer, such as arcing also create the heat, and heat also can create gases inside your transformer when it's discharged and oxidize the insulation oil or the paper inside your transformer. Bubble, um, acidity increasing, slush. All these things can yield one way or another to the end result as the gases. Meaning, if you analyze the dissolved gas inside your transformer correctly, I would like to highlight it correctly because many times we have a misaccuracy because of the wrong sampling. Many cause that cause the error and incorrect information that can lead to the misjudgment of the dissolved gas inside of your transformer or the DGA result. So actually DGA is very, very excellent tools to analyze your transformer. So right now I would like to show you our equipment here. Let's talk about it. We call it insulated G2 as I said at the beginning. I don't want to call it is a DGA equipment because if you are in this field for a long time, you know that DGA is you not no sorry. You feel that if you are going to measure the DGA, that means you have to analyze the result, which this insulogic. It is not the equipment for analyze. This equipment can measure two gases. First is the acetylene here. Second is the hydrogen. And it also can measure the water or the moisture inside of your transformer. We use the laser gas detection to measure the acetylene and thermal conductivity detection to measure the hydrogen here. And we also use the laser gas detection to measure the moisture. The unit we have the warranty for 2 years up to 5 years if you want to extend. We also have the communication, Modbus, RTU, TCP, DNP3 if you want to connect to SCADA for photo protocol. And we also can communicate through the IEC 61850 for any digital substation if you need it. We have 12 configuration solid relay, so we can send the signal from the unit to outside, such as any alarming or equipment information or any system alarm. We also have the analog output if you need it. such as tripping of some of your system, closing of the valve, or any analog signal that you need to send from the unit to outside. Our memory is around 10 years or more at least. Very simple. We also can measure or use with any oil type of your transformer. You can select those options inside of our system. And from our design, we design is to be a free maintenance for 5 to 10 years at least. For 5 to 10 years, there is some filter inside which may a little bit maybe need to be changed, but it also depends. So that's why we can warranty 5 year at least. And without free maintenance, actually this unit has been installed for a long time, but before that we have not take over, and it also can maintain for more than 2 to 3 years already without no condition environment, or don't have to maintain anything. Very simple and easy and very accurate. So right now, you have already know that our InsuLogic G2 is measuring the acetylene and the hydrogen and the moisture. So I would like to tell you a little bit that why we select all these gas and moisture to be monitoring gases inside of your transformer, because you can detect the changing of the fault in your transformer in this region here. The hydrogen will be increased or decreased depends on the fault or even happen inside of your transformer. Meaning, if you detect the changing of your hydrogen, you can detect all these fault happen inside your transformer. But as I said, it is not for analyzing. So you cannot identify what happened inside your transformer. But you can identify that something happened inside your transformer, and the likelihood should be this kind of fault because it's changing of the hydrogen. We also can select the acetylene to be the key parameter to monitor the gas happening of inside of your transformer. Very simple, because the acetylene will be created if the temperature inside of your transformer reach to 700 degrees Celsius. So you will find the arcing or any high energy discharge inside of your transformer that can lead to your uh, huge damage or severe damage of your transformer. So if there is a changing of the acetylene inside your transformer, that means you have to plan or shut down or really investigate inside of your transformer. You don't have much time left to operate your transformer. So combining between these two gases, you can protect your transformer very excellent, because you can detect something that a little thing happened inside your transformer, little fault, and if you miss this kind of fault, you have some of the huge discharge because of the huge bubble, or your transformer is going to break down. You will detect acetylene for sure in this case before its fault. So those two gases can identify most of the event fault inside of transformer that is happening inside. So it is a very excellent combination. Next is the water. Water can detect fault. No, it's not the direct fault, but water can detect something that is going to damage your installation. such as in this diagram here. If there is oxygen inside of your transformer, or the leakage that I told you before, it will create the water. That means if there is a water amount increasing inside of your transformer, it's likelihood that there is a leakage of your transformer, or the air coming out from the outside and create water inside of your transformer. And also the water inside of your transformer is the main factor to accelerate the aging of your installation. That means you have to monitor water, otherwise something may happen inside your transformer and the aging of your transformer start to increase in the tremendous trending. You can do a drying process or many things to take out the water from your transformer. Okay, right now I'm going to talk about three things that really matter or important when you measure the dissolved gas inside of your transformer. First is the sampling. Sampling is very important because if you sampling in incorrect procedure or method or the way, it will create the huge um, inaccurate in your result and misassessment of your result. Gas extraction, of course, normally when you do the sampling the oil from your transformer, you need to extract the gas out of that oil, which the process or the method to extract the gas is very important to the accuracy. If your extraction is not good enough, that means you cannot get every gas out from your oil, sampling oil. The last is the measurement of the gases. Direct and easy. Because if the gas that you extract from the oil is not measured correctly, that means you will not get the result correctly too. It's effect of the testing result, the accuracy, and the assessment. All these three is the main factor that can affect to your measurement directly. Our Insulic G2, we use the um, heat thermal convection method to pull the oil from your transformer. This method is very simple. We have a heater here inside of our Insulogic, make the temperature of the oil different from the oil inside of your transformer. And then if there is a different in temperature, there is a flow from outside to inside here, like this. Simple to understand, right? And very effective method. I would like to talk a little bit about the facts when you do a sampling here, because we have already talked about the how to pull the oil from the transformer, right? First, first is the condition when you do a sampling. You're sampling when your temperature or the outside condition is hot or it is in cold weather. Because if you do the offline sampling from your transformer, the best procedure is you must take that sampling to test as fast as possible. Otherwise, it will create some of the chemical reaction if the weather is hot and change the property of the gas inside of that sampling. Or if you sampling in the cold weather, I don't believe that your vessel that collect that sampling have the zero moisture inside. There must be some of the moisture left. So if you sampling in the cold weather, such as in the cold country, of course, in the Asia, most of the country is not cold. But just for example, it will create a droplet inside of that and create the moisture inside of sampling. So this is the first thing that can create the huge mistake or the huge inaccurate if you did the offline sampling. You have to be careful. Second is the condition when your transformer is operating. When you do a sampling, you do while it is the normal operation or high load operation, or you're doing you do a sampling while your transformer is shut down. The important is when you when your transformer is operating and have the high temperature inside, the water will comes out from the paper. And if your transformer is not operating or it is in cold condition inside of your transformer, the water will be absorbed by the paper. This is the nature of the paper inside of your transformer. It's very simple. Could you imagine that if you want to dry your clothes, you take out your clothes to be under the sun, right? And if your clothes got heating, the water will comes out from your clothes and your clothes will be dry. It's the same. If you heat the paper or the cellulose inside of your transformer, the water will comes out of your paper. I will show you the example here. Oops, sorry. Okay. This is the example that when the when the paper got more heat or increasing, you can see the bubble came out from the insulation. This is the insulation or the paper. Water that when it came out from the insulation, it will not comes out in the form of the just water. It will comes out in the form of this kind of bubble. And these bubble, if it is many enough, such as here, temperature is 142 degrees Celsius. It also can create some discharge inside of those bubble or maybe PD. Okay, this is the example. Let's go back to our slide. The second facts about the sampling is you can do many places for sampling, such as in this picture. You have like here and here and here and here. I can separate into four positions because first is the top oil far from the heat exchanger. This is the heat exchanger or the oil cooler here. If you do the sampling here, you get quite good result. If you do a sampling here, you also can get the good result because from from some of the research, the gases likelihood or have the better result if you sampling from the top oil But in this position, could you imagine that you are going to sampling a very big transformer which is still operating? How could you climb up to do a sampling here? You don't want to go out on the top of the transformer when the transformer is operating, right? It's impossible. Or even your transformer is shutting down. Some people or some of the group don't want to climb up and do the sampling above the transformer. It's quite hard to do it. So normally we don't sampling at this position, but normally it is the very good position to do sampling. And the next is the drain valve. If you're sampling from the position that far from the heat exchanger, okay, this is the very good or the best position for do the sampling because it is the easiest part to sampling. But you also have to be careful about the water inside your transformer. If you have a lot of water at the bottom of the transformer, those water is not involved with the insulation at all because those water is just be there. It's not involved. Okay, so you have to flush it out until you didn't see any water inside, and then you took the real sampling. So you also have to be careful about that. And we also have here the returning from the heat exchanger. This point is also quite good to do the sampling, but of course if there is a flow rate or your transformer is over in the operating or the cooler oil cooler is still operating, there's flow inside, you have to be careful about the flowing of the flow or the pressure. It depends. I would like to say about this because it also very effective to the effect to the position when you install um, the Zoologic G2 or the online monitoring. This is the better position because there is a gas gathered there. This is the good position, but the best position should be here, the return from the cooler, because the oil will be flow from the heat exchanger or the cooler, so you can get the sampling of the oil that circulate inside of your transformer. This position can get the result too, but the result may be a little bit slower from this position. It still can get eventually because all of the gases inside of your transformer will flow all over of your transformer eventually, but the result will be a little bit slower than this point or even this point. Okay, next fact is how often that you do a sampling. In case you don't have the online monitoring, you do a normal sampling of the DGA every time, take out the oil. This is the case study that I brought from the research approaching the relevant, cost-effective, sustainable maintenance of mineral oil field electrical transformer. They also have a case study. This is the arcing fault here. On the x-axis, it is the timeline, and the y-axis is the concentration of the gas. In this case, is the hydrogen and the acetylene here. You can see the development. This is 2018. The concentration of the hydrogen still be like 0, and it developed to 10 ppm, almost 10, not 10 yet, around maybe 8. I'm not sure. It's around that. In 1 year, in 1 year, if you sampling here, you will not found anything. Okay, you may found acetylene, but you want to sampling like every 6 months according to the recommendation. Of course, you still found it, but it is not increased temperature, increase in the high rate, right? After 2019, you can see the increasing of the acetylene here, but it is not much enough to alarm you. Maybe a little, but much enough. Hydrogen, yes, of course, from um, 8 ppm to 20. I don't think you will, I mean, shut down immediately or cut the circuit or uh, trip the transformer yet, because the increasing is still normal, still not high enough. From the June, the increasing rate changed tremendously. So in this period, the development is like June until September here. The point that shown here is the sampling time. You can see the development increased tremendously. If you not sampling often enough or frequent enough, that means you cannot found these development at all. And before you know, your transformer has already exploded already. That's why the often to the sampling is very important. Once a year, that's normal for offline. But if something really happened inside of your transformer, maybe that is not enough. Online monitoring can help you in this kind of things. It's the same case if you have like this fault, this type of fault, partial discharge. The development of the hydrogen is like, wow, almost 3 years. In this period, you also can plan to fix it, plan to change something inside of that transformer, or plan to investigate something inside of your transformer. Of course, if your starting point is like 20 ppm, increasing to 50 ppm, you still may not um, have no idea what we should do up to that transformer yet. But if the increasing rate change from this, I mean the slope, you can see the slope, right? The slope is changed. You may need to start consider about investigate all those forms inside of your transformer. Okay, so our InstaLogic G2, it is the online monitoring. We can solve all of those problems easily. You can avoid the sampling error, misstart the fault that happened inside of your transformer, because from the previous case study, you can see already that if something inside of your transformer, you have to start to monitor it. How severe of the that that fault, or what should we do about that fault, and when we can plan to fix that fault. And the very important is you also can reduce the error from the sampling position and monitor all the time. So these are the benefit that you can get if you install some of the online monitoring. You don't have to install our InstaLogic, but I could say that our InstaLogic is the excellent. Okay. Next is I would like to tell you that our extraction method is using the membrane. It is the gas permeable membrane. Very simple. You have a filter to the oil that can filter out the oil and just grab only the gas from the other side here, like this. On the left hand side is the oil. We will let the oil flow through this membrane, and the other side of the membrane we extract the gases using the we make it like a vacuum here in this side, and we pull the gas out from the oil. Very simple and very effective too. Our design is very effective. I will show you later why our design is very effective from this. Okay. The next is our gas measurement method. Like I said earlier, that we are using the laser gas detection, or the LGD here, or you could call it tunable diode laser absorption spectroscopy, very long one. You can just call it TDLAS. That's it. We have the laser diode here. It will shoot the laser out, and it will reflect the mirror between the mirror here inside of the measurement chamber. Those laser will be absorbed by the gases here, the laser wavelength, and the wavelength will be measured by the photodiode, and then you can measure the amount of the gases that have inside of this chamber. Very simple. This is the way of gas in and way of gas out. And this laser is very, very, very accurate because our equipment can measure acetylene down to 0.5 ppm, which is very small amount. We can measure at accuracy plus and minus 0.5 ppm of the acetylene. Meaning, if you have experience or measure the acetylene before, and you found that, wow, there is an acetylene inside of your transformer, you alert, told your superior, told your boss, told your owner, you have to investigate, there is something happened inside your transformer. But is it the real alarm or the fault alarm? Acetylene is very important, and the more important is the accuracy when you do a measurement that you found acetylene or not. It is the real alarm or the fault alarm. If it is real, that means you have a serious fault inside of your transformer. You have to do action. You're right. But it is not the real one. It's a fault from your sensor or your sampling or any error. It will cause a lot of cost to shut down your transformer, investigate without found anything. That's why sometimes, or many people that told you that DGA is not a good analyzing tool or something, that is not the main point of the DGA, because there's so many errors. Our Insulogic G2, from our measurement method, our gas extraction method, we can guarantee that this is our accuracy, and this is the LDL, the low detection level that we can detect. Simple and easy and very accurate. Our repeatability is also very good. 14% for acetylene, 10% for the hydrogen. Could you imagine 14% from the 0.5? This is really, really excellent too. Okay, so it is the best equipment to detect if anything inside of your transformer is happening. Any event that is happening inside your transformer, increasing in the acetylene or increasing of the hydrogen. Of course, in the case study before, you could saw that the hydrogen may start from 0 or something. 25 ppm, this is very, very small amount enough. Maybe you can find the like 5 ppm or 10 ppm, but is this really matter to measure that low amount? Not at all. Even you can measure the increasing from 5 ppm to 25 ppm, you don't do any action, right? Because it's low energy fault. Okay. So let's look into our interface here. This is the interface of the logic. We have the simple screen. The blue screen here can show you the testing result, like the right hand side of this slide. Can show the version, measurement value, and very important is it can show increasing rate or the rate of change that is really matter to your monitoring. This is the acetylene, this is the hydrogen, and we also have the moisture, of course. On the interface here, we also have the LED light here to show you the status of your system, or warning, or alarm, or there is some problem inside of your system. And we have the button to change the screen here. Very simple to use it. You just monitor. Our InstaLogic also have the light saver inside of the unit. So meaning, if you connect the equipment through any LAN system of your system, any system that connect to the LAN, you can log in to monitor it easily using the username and password here. We have a dashboard. After you log in, you can monitor the parameter of your measurement, ROC is rate of change, ppm per day or per month, or you can set it up. Okay, you have the RH percentage or the ppm percentage, ppm amount, depends on things that you want to look at. You also have the status here, and we also designed to be easily judgment, like green, yellow as a warning, yellow as alarm, or the red is a warning. Already, it depends. We also have the screen to show you what is relay is working, or the status of the relay that you set. We also can set up the relay definition or the description easily, like this, like hydrogen rate of change, or you want the second relay to be acetylene alert, or thirdly relay to be rate of change of the acetylene, or even system alarm. So meaning you can easily set up all these relay through the web browser. You don't need any special software to control, manipulate anything. Just simple web browser enough. Google Chrome, Internet Explorer, those simple software. We also can set up the threshold of the alert and alarm here, or rate of change inside of the software, or the setting easily. You can save it. You also can monitor the trending or rate of change of the measurement value. Very simple. You can select any range, such as the weekly, today, yesterday, or a month, or you can custom the date you want to look into the measurement parameter. You can take those some measurement value out to make a report of your own to send to your boss, or you can download it out through this easily. Okay, the report. We have the lock event inside of your transformer is in case of anything happen. Of the unit is very easy and simple too. We need only one valve here. Don't need two. Only single valve is enough. You need only 2 hours to physical installation, and we can do the commission later. So it's fast and easy to install, and you don't need any platform. It's strong enough and can hold to those valves easily. Summary: Isologic G2 is an equipment for fault detection and alarm. No need for analyzing, just monitor the rate of change and the parameter. It can measure the acetylene down to 0.5 ppm, so you can detect any fault that happen inside of your transformer, any changing inside of your transformer. The accuracy is also 0 plus or and minus 0.5 ppm, so no fault alarm will be occur. And we also designed for free maintenance at least 5 to 10 years. 5 to 10 years. You don't need to worry about anything. You install, leave it there, and you don't even have to check it anything. Just trust the alarm and the warning. You must trust our alarm and warning. Otherwise, you will get the real serious fault. We need only 2 hours for installation. Simple and easy. Okay? Single valve. No need for special special valve or special accessment. You can access through any web browser. No need any special software. If you have a network system, you have you create a VPN. You can also access through the internet easily. It depends on what you need to access through those parameter or into those equipment. Okay. Last thing I would like to say is normally the monitoring or the online monitoring can help you to reduce the cost of maintenance and reduce the cost of the fall, the rate of fall, and can monitor everything inside of your transformer easily. You must trust our equipment accuracy. This is the things that we can guarantee. And the last thing is, what would you like to draw your future of your maintenance? You want to do sampling all the time, or just want to go back to your home and sleep without worry anything? Let Instalogic help you through it. Draw your future. Thank you. If you have any question, please feel free to ask, and you can contact me through WhatsApp at my number or line application, or you can email if you have any question. And this brings me to the end of my presentation. Thank you.
Thank you, Smit. Thank you for your very fruitful and wonderful presentation. So now it comes to the end of it, and will be our Q&A session. If you have any questions, you may type into the question box, and we read out the questions so that Smit can answer that. And for those of you who are leaving, please remember to have us fill the survey, which you can see on the right-hand side. We'll be sending this presentation material to those completed the survey. And also don't forget to download the attendance certificate at the bottom control panel, which is an icon on the right-hand side. So Smit, are you ready to answer some questions now?
Yes.
All right, so
I will
first
answer in the Q&A.
All right, so maybe I can read out the question if you like. Yeah. So the first one is, I think you may be already answered. What is DGA?
What is DGA? I don't really understand. DGA is a dissolved gas analysis. You're analyzing the gas that happen inside of the transformer, because gases can tells you that, such as the heat has been created or some of the power has been created inside of your transformer. Is It can tell you lots of things, and those gases we are going to analyze, and the name is the DGA, or the dissolved gases analysis. Yeah.
All right, thank you. And the second one is, what is
Yeah.
BDV?
um what's the BDV? That is the breakdown voltage, if I understand correctly, which is normally, um, when you test the transformer insulating oil, you also need to test the breakdown voltage of that oil. But that breakdown voltage we will test by generate or apply the voltage to that oil. Normally we use the like OTS equipment tester from our maker. We will apply like um, 80 volt or 100 kV. It depends of your standard, and also depends of your insulating oil condition. Yes.
All right, and the next one is, does weather affect the measurements of dissolved gas?
It does not affect directly, like I said. The weather will affect when you took the sampling out from your transformer. It will not affect the oil if the that oil was still inside of your transformer, or that oil fast enough to take from your transformer back to the lab to offline testing. So of course it also have a little effect if there is a really huge change, like you are sampling like under the 40 degrees or 50 degrees Celsius, and you didn't contain anything, have a good container, you just put it under the sun, of course it will affect. So if you have a very good sampling method, you can avoid all of those things. But do you can also concentrate or have the same sampling, like all base method all the time? It also depends on the sampler. If you change the person, you also can create the different, or you have to train the new guy, or changing the company, or even changing the lab. So all of those things you can avoid it by using the online monitoring. But the InsuLogic G2 is not the analyzing. That means if something happened inside your transformer, you need to do the offline sampling. While you do those offline sampling, you just concentrate all of those process in those years. That's it. That means you can avoid all of those um, error. Okay.
All right, thank you, Smith. And the next one is, for measuring rate per hour, is it an average value and how long is it?
Um, yes, it's like an average value, because the oil will be sampling all the time, but it is not the total average. I would like to say it is the accumulate of the gas sampling from the oil. And after we accumulate the gas sampling, we will know increasing, because the unit, it is the ppm, right? The part per million of the oil. So when you do the sampling, you know the amount of the gas, you know the amount of the oil, and you get the amount of changing or increasing from the oil, from the oil inside of your transformer. How long? How long of the average? All the time. It depends on how your setup of your of the InsuLogic. You can measure every hour or measure once a day. I could recommend that you just measure once a day is enough, because when the gas develop inside of your transformer, it's not that um, disperse or distribute all over the transformer. So once a day should be enough, more than enough. You can measure every hours, depends on your setting. It's okay. Okay.
All right, thank you, Smit. And I think the last question we have is, could you please explain on the interfacial tension?
Interfacial tension. Okay. That is more on the just a moment. Could I still show them the some of the slide?
Yes, you can.
Okay, just a moment. I'm finding something. Actually, it is the. If I please correct me if I understand it's not correct. Okay, because interfacial tension is to measurement the um the property of the oil. We have lots of the property of the oil when you did a real measurement, such as the breakdown voltage, um, acetylene. So could you see my screen, please?
Yes, we can see your screen.
Okay, good. So this is the real, I mean the molecule that um, that has been created from not create has been not has been created. Sorry, it is the molecule from the insulating or many things. This is the plastic. This is the motor oil. This is the diesel or the gasoline here. We have a different type of the change and molecule, but all of these are hydrocarbon chain. So to prove those properties, we have many things. First is the physical. Second is the chemical or contamination, such as the water content as a physical, low breakdown, high particle, turbid, chemical like color. This is the question. Low IFT, changing of the tension. So it depends on what test, but the IFT test, just a moment. Here, interfacial tension. We have a recommendation. This is from the IEC. You can continue normal sampling, more focusing. This interfacial also can tell here the force required to pull the the ring through the water or the fluid. It affects the polar contaminates inside of that oil. You pulling something, you test the polar, because normally the oil is not the polar or non-polar, so it cannot conduct the any electrical. But if you have a polar contamination, such as the water, if you go back to see a water from my presentation here, just a moment. This the molecule of the H2O here. The blue one is the represent the oxygen, and the small white one represent the hydrogen here. you could see that there is no balance in that molecule. If it is a non-polar, we call this the polar molecule. And if it is a non-molecule, it change like this, like this. So it balance all every side. No electrical. Uh, good. It is a good insulation. It's not slip out of the electron. Okay, and this is the non-polar molecule. So there is some unbalance. To test interfacial is to test of the amount of this non-polar thing. If there is a big or a huge amount of non-polar, that means your insulating oil tend to can the dielectric of the quality of the dielectric will be goes down. Okay, this is the
Okay, thank you, Smit. I guess we don't have any more
okay.
time for questions, but if you have further questions, please send us email to ea.marketing@megger.com. And those who has already sent your questions here will be sending you the question answers by email later after the webinar. So thank you again for attending. Please just follow the reminder. Please have a fill in the survey and download the certificates before you close the webinar window. And the recording of this webinar will be sent to you in 2 days' time by email. Thank you again for joining our webinar today, and thank you, Smit. We hope to see you again next time. Thank you, everyone. Bye-bye.
Thank you. Yeah, thank you so much. Bye bye.